Welcome back. We are continuing with the internal resistance as well as the electromotive force, which is the EMF. So as we alluded to, we said the internal resistance is normally, by definition, the resistance inside the battery or within a battery that drops the potential difference of the battery when there is a current flowing in the circuit. And the EMF, by definition, we said it's the maximum energy supplied or the maximum work done by the battery per coulomb charge. We said we are using the formula of V equals to W over Q. Now, when we continue with these two, we'll find that now the EMF from this arrangement of say EMF equals to the total voltage when the current is flowing and the voltage that is lost inside the battery due to the internal resistance. Out of this combination, we are going to have the formula for EMF, which will be now the V according to Ohm's law is IR, which is the R external, the big R, and the V again is IR, which is the internal now. Then when you do this one maths, you will find that I is the common factor, and this will be the case. So this is the formula that you find in the formula sheet. But remember, you can use this one, which you don't find in the formula sheet. Very important formula of V external plus IR. Remember, this one is where the two graphs are coming from in this section. So the first graph being a V and I, where you will find this. And then in this case, the y-intercept representing the EMF. Y is because if you make the V external the subject of the formula, you'll find that V equals to negative IR plus E. Therefore, if you make it in the form of Y equals to mx plus C, you will find that V equals to negative R multiplied by I plus E. Y equals to mx plus c. Therefore, the gradient of this graph will represent negative resistance, negative R. That's the internal resistance. So if you want to find the internal resistance, it will be very easy. It will mean that now you can find the slope or the gradient. Just choose any 2 points, and then you will find you can use that one of y2 minus y1 over x2 minus x1. That's mathematical one. Choose any 2 points that lie on the graph, and then the slope will be negative, and that negative slope, for hypothetically, let's say, for example, you find that when you substitute, you find that the slope is negative 0,2. If that is the case, then you will say, now, okay, fine, the slope is negative R, which is negative 0.2, therefore R will be 0.2 ohm. That's how you do that. Fine, the second graph will be where now you have got this, and now you swap the axis. This is the case, then you will also have this graph, where now the slope will be now negative 1 over R. That is the slope when this is the case. Again, here the x-intercept will represent the EMF. The x-intercept will represent the EMF. Remember, at the x-intercept here, the current will be 0, the vertical axis. Again, at the y-intercept here, the x current will be 0 when the current is not flowing in the circuit. Like in this case, if you've got this formula, when the current is 0, the whole thing is 0, then what you read on the voltmeter is the EMF. Then that's why we say the internal resistance drops the voltage of the battery when the current is flowing. This one will no longer be the same as EMF when the current now is flowing in the circuit. It will be less than the original, the EMF. That is the first part, where now out of this formula, very important formula, out of this formula you get two graphs. Out of this formula you get two graphs. You will find this is the formula, then is the one that gives these two graphs. If you are doing experiment in school, you will be dealing with this one, and now you will have these two graphs, no problem. Now we move on. Let's move on to maybe again this one. Where are the two graphs? You will find that now also in that one of EMF equals to I into R plus R. Therefore you will get two graphs as well. You will find that now you will get one graph where now you have got R and 1 over I. And then also you'll get another graph where you have got 1 over R, in this case 1 over I plus an R. So this will be the case. You'll find that in this case the graph will start from here, then you'll have negative R here, which will be your normally the internal resistance, and in this case you'll find this type of a graph. So these are the two graphs that can emanate from this formula. Fine, very important. Therefore you've got 6 graphs, 2 from Ohm's law, 2 from the E equals to V external plus V internal, which is this one, and then the other 2 graphs are coming from this formula. So in an exam, be careful, the slope of the graph, the intercepts, then that will give you the information. Now we move on to this one. The last question in this, before we do one simple question, will be when now you're going to explain. Explanations will be normally 4 marks. Hypothetically, if I've got a battery and the internal resistance, and this is the most important one, V1. Now this is the switch, switch, and then you have got let's say a resistor here, R1, and I've got series parallel R2 and R3, and then this is the case, I've got an ammeter, and this is the circuit. Now what's going to happen in this case? When we explain, we are going to use this table to say whatever that you'll be doing at the end, you'll be tampering with the total resistance of the external circuit. Fine, that's what will be happening. And when you tamper with the total resistance of the external circuit, what will happen is that the total current in the circuit will be also affected. You can write R external or R total is fine. Then this too is according to Ohm's law. Those who remember Ohm's law says this too will be reasoning with R equals to V over I. Remember the relationship between R and I. So R is inversely proportional to I. This is the most important relationship in this case. And then from here now we'll have the V internal, so which is your lost volts inside the battery, and the V external, which is your voltmeter across the terminals of the battery. That's the case. Now remember these two again. These two are using a formula which is EMF equals to V plus IR. That's, remember in this formula, please be careful that the EMF and the internal resistance remains constant. So that's what you should know. So the V and I can change, but these two do not change. So if we have got the same battery, we'll have the same EMF and the same internal resistance. So now what's going to happen is that, let's say for example in this one they say I was having a switch here, now the switch is open. This one is closed, then the switch is open. Once you open the switch, then mean that we no longer have a parallel combination. Now we have got all the current will flow through R3. Therefore, the fewer resistance in parallel, the greater the current, the greater the resistance here. So once you have got, the more resistors are connected in parallel, the smaller the effective resistance. The fewer resistors are connected in parallel, then the greater the effective resistance. That's what you should know. Meaning that if I open the switch here, I'm increasing the total current, total resistance of the circuit. Total resistance of the circuit will increase. And what happens to the current? According to this one, if total increases, the current drops. The total current in the circuit will drop. And if the total current drops from this formula, if the total current drops, then mean that this product here will be also lesser. Then it will also decrease the V internal. And if the EMF is the same, let's say for argument's sake, I was having 12 volts and maybe 10 plus 2. Now this one drops to 1. I still have got 12. Therefore, now the V external will be 11. You see now, if the lost volts inside the battery decreases, the V external increase. That's what will happen here. Therefore, this one will increase. If you are very observant, you can see that there is a relationship between these two. Because some questions can just directly say, we remove one resistor in the parallel combination, what happens to the V external across the terminal of the battery? So if that removal increases the resistance, also V external will increase. If that change decreases the resistance, also the V external will decrease. That's what you should know. So the two, they are directly proportional. Therefore, in this case, if you decrease whatever that you are doing, let's say I connect one more resistor here in parallel, R4. The more resistors are connected in parallel, it means that now the smaller the effective resistance in this parallel. Therefore, the total resistance of the circuit will decrease. If the total resistance of the circuit decreases by connecting this one, or one examiner can say you connect the wire across this one. If you connect the wire, I mean that now the effective resistance of the parallel will be 0 now. So therefore you decrease the total resistance of the circuit, then the current will increase. And if the current increases, the product of IR will also increase, which is the V internal or the lost volts. Then that is the explanation. Very important, this table, because the question might be 4 marks and say explain. So we'll also deal with the typical explanation in this regard in our next session, where now we'll be focusing more on what will happen, because normally this is the last question in the question paper to say what happens to the voltage across the terminals of the battery if the resistance of the circuit maybe is tampered with. The total resistance of the circuit is tampered with. So we'll deal with similar questions here. That has got where circuits has got the internal resistance and where circuits has got no internal resistance, so that we deal with both and then we know what's going on in that. Until the next stop, let's pause for now and then we'll talk about the calculations now. We are going deeper into calculation. I think explanations now at least are clearer. We know the formulas that are involved, and in a nutshell, we know that there is a formula for series, which is R equals to R1 plus R2 plus R3. For parallel, we can use the traditional one to say 1 over R parallel equals to 1 over R1 plus 1 over R2 in this case, or one learner can say R parallel equals to 1 over R1 plus 1 over R2 all to exponent minus 1, or one learner can say R parallel equals to product over sum R1 multiplied by R2 divided by R1 plus R2. No problem. And then the other one will be the Ohm's law. R equals to, these are just a summary, R equals to V over I, remember, fine. And another formula that we'll be using here is E equals to I into R plus R, which is R external and R internal, or you can utilize also E equals to V plus IR. Also in this case, this is V external, this is the V internal, the lost voltage inside the battery. Otherwise, we can use the power dissipation in the circuit, and the energy dissipation will be VI delta T, or in this case V squared over R delta T, or in this case we can have I squared R delta T, and then the power dissipation will be about VI, and then starting from also W over delta T, and also can be V squared over R, or it can be as well I squared R. So I think with this short summary of formulas, you will know what to do when faced up with questions on electric circuits. We'll use this in the next coming sessions. Thanks a lot for now. Bye.